So I get this question a lot. What do you guys do for a living? And it's always a challenge for me to explain what we actually do here. Maybe you are in a similar field and you know what I'm talking about. So hopefully this video will explain what we do as embedded system engineers. And we are doing this in a mannequin challenge style. Let's start by showing you our studio where we do the tech talks and all the other videos. It's right over here. So as you can see, it's a small room, but we have the green screen in the back so we can have really nice backgrounds going around. We have the lights, we have the setup. This is needed for explaining some of our products, some of the technologies. We are done with the studio and the marketing. Now let's see what's next. Next thing is done is we have to have somebody to talk to the community, talk to the people, figure things out. And this is where we have Gary. This is Gary, our favorite superhero. He's always busy doing stuff. And if you ever give us a call or send an email and you had some complaint, it's usually Gary very busy answering everybody. Now, enough with the fun stuff, for real. So what we do here is we design circuit boards that are digital. Means they are programmable. So these are like small PCs in a way. They're called embedded systems. They have a processor, a really, really tiny processor, probably like my very first computer. And that's inside a small chip. And this chip controls the rest of the circuit, and that's a digital circuit. Kind of like what you have in your smartwatch or a phone, but that's on a much larger scale. If you look at it from the low end, that would be more like a microwave. And I'll talk about that in details later, but I want to show you the steps we take to create a product. Now, after we made videos and we did some marketing earlier, now it's time to design the circuit board. Now, after we talk about the circuit, we draw it on a piece of paper of what the circuit will contain. And if you look at the monitor, on the left monitor up there, you can see that's the schematic. This is where we actually take that design from an actual paper and then put it on the PC. And then that schematic is what determines what components go on the circuit. Now, after the circuit is done, we have to write some software for it. Remember, this is a digital circuit, so there's probably software involved in this age, in digital world. So these circuits over here come to our software engineers who would sit down and do some programming on the circuit. They do some testing. There's always analyzers involved, scope, all kind of equipment and wires that is needed to essentially test the circuit, make sure it's all functional, and write the software for it. After the circuit has been designed and the software has been tested, all seem to be working, we are not actually done. This is where quality control comes in. So in quality control stage, we're checking circuits for noise, making sure it cannot be easily damaged. So over here, we're setting up to test for EMI. We have an analyzer. We're checking for noises on a circuit. And this is a very important step for passing FCC CE, for example. Now that we have designed the circuit, we've verified everything is okay, we're ready for production. This is where production happens. These are the raw components. They come on reels. Some of them come on trays. The next thing we would need is the raw circuit boards that go into this first machine. This is a pretty fancy machine that actually is a printer that prints solder on the circuit board. It's a jet printer, basically. Instead of putting ink on the circuit, it does soldering on the circuit. Once the circuit has gone through this stage and the solder is printed on the circuit goes through the conveyor to the next machine. This next machine is basically is placing the circuits, the components on the circuit board. So for example, right here, we are setting up, we have one of the reels going into the machine. The machine will be picking up those itty bitty tiny small components and placing them on the circuit board. Now, the solder at this point is still paste. It's like a toothpaste. It's really soft. It just holds the parts in place, but it's not completely, it's not flowed yet, reflowed. So this is where the circuit go into the oven. Right here we see the oven. The circuit goes from one side, it stays in there for about half a minute, and then it comes out of the other end with the components soldered at this point, and the circuit is ready for through-hole and for testing. Once the circuits are off the oven, this is where they are either ready for testing or they are ready for through-hole components. Now, through-hole components are basically through-hole. They go through a hole that goes on the circuit. Surface mount components are the components that sits on the surface. So there's paste, the component sits on top, it goes through the oven, gets reflowed. That doesn't work for through-hole components. Now, they have a separate machine for that. The through-hole components are basically the components are put through holes, and these go through this machine that there is like a solder fountain, if you will, that goes under the circuit, and then this places the solder on the circuit board. And over here we have we stuff the circuits. Obviously, the machine does not place the components on the circuit. We have to manually stuff the circuits onto the components onto the circuit, and then once it's fully stuffed, we can take those components, the circuits, and place it inside the machine that will reflow that place the solder on the pins. Now that the circuit is soldered, we have through-hole, we have surface mount components, it's ready to put some software on it, flash it, test it. Different circuits go through different stages. So this over here, we're for example, putting the software on the circuit boards. We're placing the serial number on the circuits. Some circuits go through maybe other stages. We may be doing like another phase of testing the circuit boards. That is also a possibility. Bagging them, putting them in boxes, depending on the product and how it's packaged and how it needs to be tested. The very last stage, obviously, is putting things in boxes and getting them ready to go. Some of them go in retail boxes. This product, for example, goes in a retail box. So we have to close up the boxes and put the circuits inside and get them ready for shipping. And from here, they go to your favorite shipping company, right to your doorstep. So that was it really for circuit design from beginning to the end, software production, testing, packaging, products out the door. But I want to talk to you slightly about what actually happens inside these circuits. Let's take a microwave. That would be the easiest example. So this is a microwave. This is the door. And then you have like a panel over here. You have some buttons going around. You have the screen. And then you have like a big button to push and open that door. So this is the only thing that's really mechanical about this. This is a membrane switch. These are buttons. We talked about them in a separate talk, and a display. Internally, if you open a microwave, don't do that, but if you happen to open a microwave or a professional open it for you, inside you would find a circuit board. This would be mounted like right behind these buttons, and then there's a wire or a bunch of wires going from the display to, let's say this is the display. There's a cable that goes here to the circuit, and then these are the buttons. And then from the buttons, same thing, there's a cable that goes here that has multiple wires. This is also connected internally to that heating element that is used to actually heat up the food inside, and maybe a motor that spins the food inside. And then we have a display and a keypad. But how that actually works, inside there is a mini computer, just like a computer that you use, just like your smart mobile phone. There's a processor inside, and this processor, instead of it being connected to, for example, a keyboard on your PC or a monitor, or on your phone, it's to touch screen and a really nice color display. Over here, it will be connected to, there are pins over here coming from this processor, and these pins are connected to the buttons. For simplicity, let's think of each button connected to a wire to this mini computer over here. Really, really mini computer. By the way, this computer nowadays is smarter than my first computer on this like really tiny chip, a lot smarter than the giant few $1,000 computer that I first got years and years ago. And then the display, same way. You would have wires going inside, going to this processor. So what is inside this processor? Well, this is the processor. We're going now one step down smaller. Inside the processor, we call it a microcontroller. It's actually, there is a central processing unit, the actual processor, the CPU. So this is the central processing unit that sits inside. This is a circuit that understands some sort of a computer language. It reads instructions and executes them, like take this, add it to that, set this high, set this low. It does different operations. It's very hard to explain it without getting into deep details. But then this processor, this will be just like the processor on your PC. Again, much, much smaller scale. or this could be as smart as my first computer years ago. Now this, remember, this is one package. This is the chip. It has like, if you look at a circuit, you see like has too many feet, looks like a bug. This will be the processor. Inside the processor, there's also RAM. This is random access memory. This is like in your PC when you go buy a slot of RAM and add it to your computer or your laptop, or when you buy you look at specification for a phone, it tells you how much RAM in there. But then, for example, on a PC, you would have gigs and gigs of RAM. On a microcontroller, you would have 16 kilobytes. That's 16,000. So that's 16,000 versus billions of bytes of memory that you would have on a PC. Again, this is a much smaller scale. We don't have graphics and video playback and internet access. So this is RAM, just like the RAM you have on your PC. And there is flash. Flash is, it's like the hard drive on your PC. Nowadays, new PCs are solid state, so they actually have flash inside. So just like this, similar to this flash. Your phone has flash. Your SD card is flash. So this flash is built inside the processor. Now, once we manufacture the circuit, the processor doesn't do anything. It's like you bought it in a brand new computer with nothing on it, not even operating system. You plug it in, nothing happens. So to an extent, I know somebody's going to be picky there and say, oh, well, there's a BIOS. So to an extent, your PC wouldn't do anything. Now, what we do here is after we are done, or let's say we are a microwave manufacturer, once we are done, we connect the circuit to a flasher or a programmer device that loads our software somehow onto the flash memory. Now, the next round, when we power up the system, the CPU will start looking at flash, just like the PC looks at the hard drive, and boots up. And then it uses RAM to function. So this is it, basically, what we do here. We work on the circuits. We work on the software. Much smaller circuits, much smaller software. No, we don't work on PCs. Don't ask me to build your next PC. Don't ask me to help you with your PC problem, please. We do embedded systems. I hope you enjoyed this video, and we'll see you next week.